In this video, we're going to look at how to find, in this video, we're going to look at how to find all the factors of 14, and that is all the numbers that can go into 14. For a small number, for example, 6, we can do that by checking the numbers from 1 to 6 to see which one can go into 6. So for example, we start with 1 does go into 6, and then 2 does go into 6, and then 3 and 3 goes into 6, and the next number is 4, and 4 doesn't go into 6, and then and the 5 doesn't go into 6, and then also we found the 6. Well, the big numbers like 1400, it would take a long time if we want to do it by this way. So what we're going to do is we're going to look at the factoring, the prime factorization of the number. So here it's given. If it's not a given, we can also use the divisibility test to figure this out. So we just keep breaking down. So we start with 2, and then another 2, and another 2, and then 5, and 5, and 7. So we will be able to see that 1400 can be made by multiplying 3 copies of 2 and 2 copies of 5 and 1 copy of 7. So notice that the exponents here, they show us how many copies of this number would be in there. And for number 7, it doesn't have an exponent, but we should know that automatically we assume it means 7 to the first because it's 1 copy of 7. Now, a factor is a number that can go into 1400. Now, we already know what prime numbers can go into 1400, which are 2, 5, and 7. So that tells us if a number, of course, these are only the prime numbers, but when we found the factors, they don't have to be prime numbers. But we know any number, we can always use them, use the prime numbers to make them. So if a number can go into 1400, they must be made from certain number of copies of 2 or 5 or 7. So this is what we're going to do. It can have any number of copies of each prime number. And so we have to, if you look at the table that I made here, so the first case I did here is I pick 0, and then I pick another 0. I pick 0 for 2, and pick another 0 for 2, and pick another 0 for 7. And another thing we need to know is when we raise a non-zero number to 0, we get 1. So if we have a non-zero number raised to 0, we will get 1. So in this case, we get 2 to the 0, which is 1, and then 5 to the 0, that is 1, and 7 to the 0, which is 1. What this means is we're not going to take any of these prime numbers, and which will automatically give us 1 times 1 times 1. And when we multiply 3 ones, we still get 1. And we know 1 can go into any number. So that means if we don't take any of these prime numbers, 2, 5, and 7, we're going to get the smallest number that can go into 1400, which is 1. But you could also take, let's say, maybe 1 copy of 7, but not going to pick 2 and 5, which means 2 and 5, they automatically become 1, the 2 to the 0, 2 to the 5 to the 0. But 7 to the first gives us a 7. So when we multiply 1, 1, and 7, and that gives us 7. And we know 7 goes into 1400. Okay, so the thing is, we have to make sure the difficulty here is, what can we do to make sure we pick all the different combinations of number of copies of 2 and 5 and 7? All of them have to be different. So if you look at my answers like 0, 0, 0, 1, 0, 0, 2, 2, 0, so all the combinations are different. One thing we could do is, one technique we can use is to make a tree diagram. So for example, when we look at the exponents of 2, So for example, the exponents of 2 is 3, which means we can have at most 3 copies of 2 there. We can choose not to pick a 2, which means 0 copy of 2, or we can choose to pick 1 copy of 2, which is 2 to the first, or we can pick 2 copies of 2, 2 to the second, and or we can pick 3 copies of 2, and that's at most we can pick, because with the breakdown, the factoring doesn't show that we have 4 copies of 2 there. So the exponents of 2 can only be either 0, or 1, or 2, or 3. So similarly, we can see that the exponents of 5 can be 0, which means we don't take any copy of 5, 1 copy of 5, and 2 copies of 5. And finally, because the exponent of 7 is 1, so that means when we pick the prime factors of 7, the prime factors for 7, we can either choose not to pick it, which is 7 to the 0, or we can pick it 7 to the first. So here I'm only going to list all the different combinations of the exponents. So like these ones, 0, 0, 0, 1, 1, 0, 2, 2, 0, to make sure we have different combinations of these. So let's start with exponents of 2. Now notice we have 4 options. So we can either choose 0, or 1, or 2, or 3. So 0 and 1 and 2 and 3. Now let's start with the 0, which means we don't even choose a 2. And we're going to use 0 as sort of like a root to start growing branches. And notice for the exponent of 5, we have 3 options. So for when we can pick 0 as the exponent of 5, or we can pick 1 as exponent of 5, or we can pick 2 as exponent of 5. And notice that for each option of the exponents of 2, we can pick 0, 1, 2 for the exponent of 5. So the case I'm showing you here is, okay, so I choose exponent 0. I choose 0 for 2, but I'm going to choose, I could choose for 5, I could choose either 0 or 1 or 2. And similarly, if I choose 1 for 2, which means I'm going to choose 1 copy of 2, I also have the same 3 options for the exponent of 5. And same for that. If I choose 2 copies of 2, I also have 3 options for exponent of 5. And same for 3 copies of 2. Okay. Now, we're going to look at the end of the branch, each branch. So the first one you're seeing here, this 0, what does this mean? It means I choose, if we go through the branches, I choose 0 for 2 as the exponent of 2, and then I choose 0 for the exponent of 5. And now, what's the next option? That is to choose exponent for 7. And notice the exponent for 7, we only have 2 options. Either we choose 0 or 1. So similarly, for each of these branches, and we will have to grow another 2 branches, 0, 1. So 0, 1, and 0, 1, 0, 1, and 0, 1. I kind of have to squeeze everything here. And 0, 1, and 0, 1, 0, 1, 0, 1, and 0, 1. If you have enough room, you could line up all of these 0, 1s. So now I went through all the options. So now let's use the tree diagram. This is called a tree diagram because it kind of looks like a tree, growing a lot of branches. And so all you have to do is to follow every single branch. So you always start with options of 2, exponents of 2. So you start with the first option, 0. And you go through the first option of exponents of 5. And then you go through the first option of exponent of 7. So now if you look at this tree branch, you are going to get a combination of, let's list these three numbers, 0, 0, 0, and which is what I put for my first option. And the exponents for all of them are zeros, so 0, 0, 0. Now let's start from the beginning again. I still choose 0 for the exponent as the exponent of 2, but then we're going to choose, oops, sorry, I missed the option there because there's a 1 there that I haven't tried. So we're still going to choose 0 for 2, choose 0 for 5, but we can vary the exponent of 7 by choosing 1. So if you look at the root, we just go through, it's 0, 0, 1. So this is the second option, 0, 0, 1. As you can see, I have 0, 0, 1 here. And of course, after you do that, you multiply everything out, and because 2 to 0, 1, 1 times 7 is 7. And so you can do the multiplication yourself. The next option is to go through, start from 0. And so 0 for 2, 1 for 5, and 0 for 7. So now we got the option 0, 1, 0, which is the next option, 0, 1, 0. And then, of course, the next one will be 0, 1, 1. So we get 0, 1, 1. That is my next one. So all the exponents that I got come from the tree, and this will be more organized, so you won't miss anything. So the next one, 0, 2, 0. So as you can see, I have 0, 2, oops, sorry, 0, 2, 0. The next one will be 0, 2, 1. So I have 0, 2, 1. The next one will be 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1. And then start over, 1, 1, 0, 1, 1, 0. 1, 1, 1, 1, 1, 1, and then 1, 2, 0, 1, 2, 0, 1, 2, 1, 1, 2, 1, and 2, 0, 0, 2, 0, 0, 2, 1, 2, 0, 1, 2, 0, 1, and then 2, 1, 0, 2, 1, 0, 2, 1, 1, and 2, 1, 1. Next, 2, 2, 0, 2, 2, 0, 2, 2, 1, 2, 2, 1, and now 3, 0, 0, 3, 0, 0, 3, 0, 1, 3, 0, 1, and then start over, 0, 3, 1, 0, 3, 1, 0, 3, 1, 1, 3, 1, 1. Finally, 3, 2, 0, 3, 2, 0, and the 3, 2, 1, 3, 2, 1. So after we go through all the combinations, and this tree will guarantee you don't have any repetitions and you're not missing any combinations. So now you just need to multiply everything out, which I did here. And just to pick an example, this one would mean 2 to the third, which means 8. 5 to the first is 5, and 7 to the first is 7. So you multiply 8 and 5 is 40. 40 times 7. Oh, I actually made a mistake here. So that should be 280 here. And so this way, all the numbers we get should be of all the factors that can go into 1400, which we have 24 of them. So 1 goes in the 7, the 5, 35, and so on.